Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 14th. Brought to you by Vunabaka.com, a new surf and water-based residential community in the island of Fiji. First up, we take a look at significant wave heights for the South Pacific Ocean. This based on the 12Z run of the model, Sunday. Not a whole lot going on, a little bit of activity in the far southeast Pacific, and that's it. We put this into motion. We see a little system forecast in the Tasman Sea. What is that, 24-foot seas aimed somewhat towards Fiji, but not a whole lot going on. A zonal flow has taken over the jet stream. No significant gales of interest are forecast. Notice a little system here was at about 36-foot seas Thursday night. Another system pushing into the Tasman Sea as well, 20-foot seas. Maybe pushing, what is that, about 24-foot seas. Again, more swell for Fiji. But for the greater Pacific Ocean, South Pacific Ocean, not a whole lot going on. And then just recently, this one little spurt here just showed up on the models east of New Zealand. This on Sunday, a week out, if it's believable at all. And with only 22-foot seas and fragments. No swell of interest to result except for maybe Tahiti, and that's it. But we look back a week ago, Sunday, the 7th of September. A small storm started to develop south of New Zealand. We'll put this into motion. It peaked out by Sunday evening, 55-foot seas. These were 55-foot seas. There was a couple of good satellite passes over, not directly over the core, but in the fringes, and basically confirmed that this system developed pretty much right on track with what the model suggested. Anyway, the most of the fetch was aimed basically due east to just a little bit north of east, but still, given 55-foot seas, decent swell radiated out. Currently that swell is just starting to hit Hawaii now. Buoys are reporting swell sizes in the 3 to 4 foot range at 19 seconds. That should fill in pretty decently and be decent by Monday. But again, most of this energy was not pushing well up the Great Circle Pass to Hawaii. This swell also hit Tahiti earlier in the week. Thursday, surf size was in the 17 to 20 foot range on face. But this Tahiti made a good sized shadow and pretty much is going to block out swell, not all of it, but significantly reduced size from about Monterey Bay down to about midway down Baja. So we'll look at the Great Circle paths here relative to Northern California, and we'll put this back. Watch this. When the system was just about at its just before its peak here, and I'm having a hard time seeing that, but that's about the 208 degrees. So there was good energy going up like the 210, 208 degree pass, which is barely shadowed by Tahiti. It's really about 210 is the effective cutoff when you get a hard wall here, and then the other side is about 203 degrees. So relative to Northern California, it was pretty much shadowed, but Southern California was even worse because we'll go back and look at this. So here's Tahiti here. Here's the main shadow pretty much runs right along in here. It starts up at about 214 degrees. And you can see this thing was in the shadow the whole way. So not a whole lot of size, regardless of all the hype expected for Southern California. So you either need to get up into Northern California or down into Southern Baja or Mexico to get anything from this system. Anyway, we'll roll that out into motion. You can see by about Monday night, it was pretty much over, and that was the end of it. And there hasn't been anything that's developed since then. And given the long-term look at the models, there's just really nothing expected for the Southern Hemisphere. So we're going to start focusing on the Northern Hemisphere because it does appear to be waking up. Already earlier this week, there was a system that developed over the Dateline, Northern Dateline region, 30-foot seas, swell hit Hawaii, a couple feet overhead. Small energy moved into California, and now we have yet another system that formed. Actually, it was 25-foot seas, and we'll get into that a little bit earlier on Saturday, but still 19-foot seas currently just south of the eastern Aleutians. This will make yet another swell for the California region, mainly from Point Conception northward. Also, tropical system Hurricane Odile off of Mexico, and another tropical system approaching, if not moving, over the northern Philippines. And if you look at the models, there's more behind that. So things are starting to wake up in the North Pacific, and not a moment too soon. So let's take a look at the jet stream over the North Pacific Ocean. These are winds up at about a little bit above 30,000 feet. These winds help support the formation of storms and also help direct their tracks when they do form. What we're looking for is a trough. We're in the northern hemisphere, so we're looking for a trough that bows to the south. And remember, northern hemisphere, we were looking for troughs bowing to the north. Now we're looking for a trough bowing to the south. That is, would help support a counterclockwise circulation in mid-levels of the atmosphere. Currently, we're not seeing that. We're seeing a bit of a ridge here, a little bit of high pressure in the upper atmosphere over the dateline region, and then something right here that almost looks like a trough, but not quite. But good amount of winds here, 130 knot winds in the jet stream. The jet stream is cohesive, a little bit of a split going on here as it pushes off towards Japan, but still not bad. If this was a super El Nino year, this is the pattern you would want to see in early August. We're in early to mid-September now. We're seeing still reasonably decent, nothing great. Considering the pattern of the past couple years, we'll take it. Anyway, so jet stream, trough trying to get going. This is supporting the low that we saw over the eastern Aleutians in the previous frame. We'll roll this out. Notice the trough tries to get a little bit more developed. This suggests low pressure in this area come Monday or so. Okay, and reasonably strong winds. What is that, 140, 150 knot winds in one pocket there, but that's in the ridge. Play this out. The jet stream holds together nicely. Bit of a trough here again. Continues to develop. Not a lot of winds in it. This is by Wednesday off of Northern California. Low pressure just off the coast would be the expected result. And the jet looks to be building and looking solid behind by Thursday. We kind of get into this zonal flow going, but then we're into Friday. It looks like a new trough starts to develop in the Gulf. Not particularly well organized, but then here we get into Sunday. We're a week out, but look at this. This is 150, 160 knot winds, a broad trough starting to set up in the Gulf of Alaska. So if you are in an El Nino sort of situation, this is exactly what you would expect to see. El Nino, the active phase of the MJO, almost interchangeable, only El Nino lasting much longer for a whole season, supports storm formation in the Gulf of Alaska and the Dateline region. And here we go into a week out. If you believe the models, things are looking pretty nice. Cohesive, unsplit jet with 150 knot winds, certainly a nice tease. Alright, now we're looking at surface level wind, surface level pressure. Notice the low pressure system, about a 980 millibar low. Notice it's north of the Aleutians, the core of the low. But all the fetches south of it, 30 knot winds right now. Actually, there were 35 knot winds back here on Saturday. That helps support 25-foot seas. But now you notice the system's basically falling apart. We have our hurricane off of Mexico here. The other system off of the Philippines will put this into motion. And not a whole lot of high pressure. 10-20 millibar high. But notice, the normal northeast Pacific high that would be here is effectively gone. Just this system here. Roll this out into motion. This system up here, the low in the Gulf starts fading, but another little low starts forming here and gets a little bit of a gradient going with the high pressure over the Dateline region. And come Tuesday, we're into 30 knot winds, pretty much aimed south, halfway in between California and Hawaii. Maybe some sideband swell result for the islands. And another low pushing over the dateline, moving towards the Gulf, 35 knot winds. You know, that's enough for maybe 13-second period swell if it's big, if it covers a large enough area. This kind of looks a little bit on the small side. Notice the low continues off the California coast, actually south winds for Northern California. Cold front sort of situation, not really cold, but still south winds, probably no rain, maybe a drop of rain for the extreme north coast here. That moves into Oregon. This low sort of just fades out, but still covering a good size area, and still no real high pressure in the forecast. We continue to roll it out, and another low 168 hours out into 180 hours starts forming in the Gulf, with yet more off of Japan. So the inference here is that though nothing solid in terms of swell production is forecast, there's lots of hints of a low pressure pattern getting organized. Next, we'll take a look at significant wave heights for the North Pacific Ocean, and we're actually going back in time here. Just give a little quick run through. Here's the system that developed on the dateline last Saturday. This is a week ago. 30-foot seas. That swell has already hit and gone, but notice it looked pretty decent for our early season. And then Feng Shen, tropical storm Feng Shen, pushed off Japan, tracking northeast. It has put swell in the water that is working towards Hawaii. Very small swell. Notice it's just a tiny little area. So, and most of the data suggests that the wave model is overhyping the size of the seas. It was only in about the 24, 25 foot range. So, but a little pulse of energy might result for Hawaii. But then that system hit the dateline, kind of, I wouldn't say went extra tropical, but turned into a cold core low, and this set up the fetch that resulted for Saturday. That was actually 24-foot seas, and even that stretching it a little bit. But those were aimed. We'll take a look at the Great Circle Pass here. Relative to Hawaii, about the 347, not so well. All the fetch was basically cutting across the Great Circle Paths. But into Northern California, absolutely well down the 308 degree path. The problem is the swell is going to be pretty much too small for Southern California and kind of cut off. We're talking about 311 degrees here, so not much is expected for Southern California. Still, that system petered out, and then we're moving into current time now. So we're into Sunday night. Basically, the system dies out. We roll on out. And then we have another low that works its way into the western Gulf of Alaska. Actually, this run of the model now is suggesting, what is that, 22, 23-foot seas. So that, if it happens, is well placed for Northern California, about the 306 degree path. I mean, nothing huge, just like 13, maybe 14 second period swell. To north pretty much for Southern California. And we can put it back here, but see, way too east really to have any impact on Hawaii. So this is really a Pacific Northwest, British Columbia, northern into central California sort of swell producer, assuming it forms. And again, this is on Wednesday, Thursday time frame. Then after that, we see another little pulse of activity trying to organize here into Saturday, but doesn't really do it. And we're 180 hours out still, just by virtue of the fact, what is that, about probably 15-foot seas. That might be good for wind swell for this area here, and yet another system behind that. So it looks like the North Pacific is trying to wake up. Whether it's successful or not, whether the models are telling the truth, hard to say, but it's about the right time of year, and we certainly could use it. Next, we take a look at long-term forecast indicators. We're looking for the active phase of the Madden-Julian oscillation. That supports storm development in the North Pacific during fall and winter months. We're also keeping our eye on a potentially developing El Nino. So, Southern Oscillation Index here. Negative numbers represent the active phase of the MJO. If they're negative over a long enough period of time, they also suggest El Nino. Currently, the daily Southern Oscillation Index, attributable to low pressure over Tahiti, minus 14.74. The 30-day running average, minus 9.8. The 90-day running average, minus 7.88. Steadily going down. This is good. If El Nino were in play, you want to see this 90-day average continue downward. So, but at this point in time, we've been in a steady negative number regime, daily numbers and monthly numbers, and you can see the 30-day average is going down slowly, and this has been going on now for a good bit of time. So this is all heading the right direction. Here's a graphical depiction of the Southern Oscillation Index over the past 2+ years. We thought we had El Nino going in 2012. That faded out. SOI numbers went positive. Then we had a big dip in the January to April time frame, and a large Kelvin wave, westerly wind burst, was generated in the West Pacific. Resulted in warming in the East Pacific, but then we lost all our ground, and now here we go again. This is more of a steady, not as abrupt sort of decline, and we're almost back to where we were in the April time frame, and this point was actually the same, if not lower, than the July time frame. And prior to that, the last time we saw any numbers even close to approaching this were the El Nino of 2009. So we're in that territory, trying to make headway in fits and starts. This El Nino is not particularly strong. It's having its issues, but it is progressing, and this is the right time of year for it to be making this negative progression. So let's take a look at surface level wind anomalies. These are wind anomalies from normal. Actually, this is the 850 millibar chart. It's what most people use to depict surface level wind anomalies. It's actually up about 4,500 feet. What we see, and we're really limiting our view from about 135 to 140 east to about, let's say, 170 west, and just maybe 4 or 5 degrees either side of the equator. So this box here, we see a little bit of westerly anomalies, and that's what you'd want to see if the active phase of the MJO were occurring. And then more so as we get over into south of Hawaii. But the Kelvin wave generation area is mainly bound in this area here. Once you get too far to the east, west winds or west anomalies don't support Kelvin wave generation. But the other thing to look at here is there is no easterly anomalies. Easterly anomalies are trades, enhanced trades, and that shuts off Kelvin wave development. We've been in basically this sort of a pattern all year long now. And then looking further to the east, we see actual westerly anomalies here. Again, here's Hawaii, south of Hawaii, pretty much going from the date line all the way to south of Baja or so, and then actually it tries to almost get going as you work your way into the Galapagos again. But this is a generally good pattern. A week out, same sort of chart. Here's Australia, the Philippines are up here. We see light westerly anomalies, very light westerly anomalies. They really don't even get going until you get to the date line. The Kelvin wave generation area is basically neutral. And then as we go east, we see the west anomalies fade. So basically just kind of a neutral, normal for this time of year wind pattern is expected. Nothing strongly indicative of westerly wind bursts, at least up at the 4,500 foot level. But the TAO array, these are actually buoys down at the ocean surface with sensors and not modeled, any of that kind of stuff. Clearly, this is for 3 days now. They're depicting westerly anomalies. This is good news. So this is supported. This has been going on for about 3 or 4 days now of this kind of strength. We'd call this probably modest strength westerly anomalies, and it continues in this whole area. So that helps generate. That will help the existing Kelvin wave get more momentum, and we'll get more into the details as we go into the subsurface profile. But let's go look at the long-term models and see what's going on. So next we want to go out 2 weeks. This is the statistic model. It suggests these yellow anomalies are the inactive phase of the MJO, more surface reflection off the ocean. This is outgoing long wave radiation forecast, mildly suggestive of the inactive phase of the MJO. The dynamic model is even more in that trend and has been. The statistic model's kind of been wavering on and off, but the dynamic model has consistently been showing some sort of inactive phase of the MJO developing in the West Pacific 2 weeks out. Other data suggest it's unknown. The models are having a hard time, especially when you get into these sort of borderline El Nino situations. They have a difficult time scoping out what's really to come. And then finally, the upper level jet stream model. The oranges and yellows again suggest areas that are not supportive of precipitation, which generally equates to the inactive phase of the MJO. They're showing something like that occurring as well, sort of corroborating what we saw in the previous models, and that's supposed to continue working its way east, moving into Central America sometime the first week in October, and then behind that a very weak active phase of the MJO following. If El Nino were in play, one would expect to see a very weak MJO signal. Not much in terms of inactive phase, not much in terms of active phase, just kind of this slightly bias towards the active phase with this continued bleed of westerly anomalies and then periodic bursts of stronger westerly winds depending on how strong the El Nino is. At this point, we have seen no significant westerly wind bursts since April and don't really expect it to happen, but at the same time, we've seen no evidence of trades, and these periodic pulses every week or two of a week westerly anomalies, then it backs off. That's all you need, though, to get Kelvin wave going. And once you get Kelvin waves forming and working their way to the east, that sets up the warming surface water temperatures, and that's what gets El Nino going. So let's go take a look at what's going on at the surface. Here we go. Surface level temperature anomalies, differences from normal. The hallmark El Nino area, that is the Nino 3.4 area, is bound by this little area right here. And it doesn't look like much, but clearly there is warmer than normal temperatures in here. About a half a degree, maybe some peaks a little bit more, nothing dramatic, and lots of warm water over here. The thought is that there is a Kelvin wave in flight, and we'll get into that in a minute. It's going to erupt. All this warm water is from a previous Kelvin wave, the one that was formed in January, February, March, and April and erupted in the late June time frame over here near the Galapagos. As this warm water builds here, it starts advecting off to the west and starts filling in this region. All this warm water in turn helps change the way the jet stream configure, bringing it further south, making it more energetic, picking up tropical moisture, forming extratropical storms and then stronger winter storms, and thus creating more surf. The issue, or not the issue, actually notice the entire North Pacific Ocean is full of lots of warm water. On the contrary side, there is warm water down in this region, but there's still this pocket of cooler than normal water here. So there's sort of this strange imbalance going where most of the warmth is in the north, not so much to the south. But still, it's creating this general warming pattern in this area. It's enough to get westerly wind bursts going and Kelvin wave developing. And so this looks like a weak El Nino sort of situation. Notice no cool water here off California, indicative that high pressure that's normally here rotating clockwise has been it's been all but gone for months now. Since, I mean, the spring there was no really strong north wind effects, no upwelling in this region. Whatever upwelling you see is due to tropical activity. We did have a little bit of cooling in this region in the July time frame and early August. That was from an upwelling phase of the previous Kelvin wave, but that's all filled in now. So things are actually looking pretty good. Weak El Nino-ish, maybe modest is what this is looking like. One could even make an argument to say if it's weak enough it'd be a Mendoki El Nino. We're not going to get into that. But at this point in time, no indications of La Nina, no indications of even a normal, just a flat neutral. It's definitely on the warm or biased on the warm side. And here's another way to look at it, sort of zoomed in on the equator. Notice 1 degree anomalies here in the west. This is where Kelvin wave generation would be occurring, actually from 140 over to about 170 right in here. And we have westerly winds, of course, that we saw earlier. And we have half a degree or warmer temperatures going the whole way to about 110 west. And there's actually some warm more back here. Certainly not anything cool, and if anything, the expectation is it's only going to get warmer over time. So and this has been pretty much going on for months now, so there is some degree, or our suspicion is there's some degree of energy being imparted to the jet stream, and some coupling, weak as it may be, between the warming here and the atmosphere above it, and that's what we want to see. Next, we take a look at subsurface temperature anomalies. So here's the far west Pacific, 140 east. Here's the Galapagos Islands over here. We're looking down into the ocean surface. Here's the TAO buoys. Notice some more of them are starting to come online. These little X's are the sensors on the buoy's anchors. This is absolute temperatures. And then down here, the more important measure is the deviations from normal. This is modeled data. It's trying to fill in the gaps between the buoys, but you get kind of a general sense of, hey, it's all warm. It's 1 degree or greater anomalies in this area. That is the Kelvin wave generation area here, and all this water is flowing in this direction towards the Galapagos. And we do have a pocket here of 3 degree anomalies is what it suggests. There's other data that we're going to take a look at now. Here's a different model of the same data. Notice it's suggesting 1, 2, 3, 4, 5, 1, 2, 3, 4. 4-degree anomalies here in this core. Maybe that's a little overstated, but regardless, notice there's no cool water save this one little pocket here, and that's going to be all but gone shortly. This is the new Kelvin wave pushing towards the Galapagos. More warm water. Notice the channel here pushing down, getting ready to fill in. This is interesting too. All that water, the expectation is pushing this direction, and as this water works its way to the east, it actually sort of gets more concentrated and warms up. So though you might have, let's say, 1-degree anomalies here, it turns into 2 or more degree anomalies by the time it gets over here. Then all this will erupt on the surface by the Galapagos and make that help feed that warm pool that we were looking at in the previous charts. So this is good news. Help is on the way, and more behind it with more westerly wind bursts. The expectation is that this pattern will continue for the next several months and help feed the building warm pool, thus giving us El Nino. And here's one other view of that. This is JASON-2 satellite data depicting surface height anomalies of the ocean. That is, the ocean is literally, in this case, 5 centimeters higher than normal, and in some pockets to 10. 5 centimeters here. That all suggests that there is warm water at depth. And so just another confirmation that there is a Kelvin wave being generated. It's got a nice little spike here. What is that? Approaching south of Baja, and more behind it, all pushing to the east, all going to backfill into this area and then gurgle up to the surface and help build the warm pool and thus give us more energy to support El Nino. And finally, one more image. This sort of puts it all in time sequence. October of last year. This is upper ocean heat anomalies. This is the top 300 meters of the ocean. You can literally see there was one Kelvin wave that came across even in the early fall, another one in October, then the big one January, February, March that worked its way into the Galapagos in about the May, June time frame, and then notice the cool upwelling phases in between. And now here's our next Kelvin wave developing, and this just recently updated with in the past day or so with this new data. This looks much more impressive than it did a week ago or 2 weeks ago, with some decent anomalies starting to develop. The interesting part is going to see how many more months beyond September does it go. Does it go into maybe October, November, and then it takes 2.5 months to work its way the whole way across the Pacific Ocean. So that would give us warm water past the December, January time frame, and that's typically when El Nino peaks. And finally, the forecast for the Nino 3.4 region. That's that region between about 170 west and 120 west that we were looking earlier. This is very interesting. Things have changed here in a good way, and only in the past about 2 days. So the usual thing was anomalies, 0.5 degree above normal by October, peaking out. Back up to 1 degree. It was down to about 0.085. Now we're back up to 0.1 degree in the December-January time frame. But the even more interesting thing is, rather than peaking out and then ramping off as one would expect with the warm waters dissipating in, let's say, the April-ish time frame, now it's suggesting a steady state almost into June, not into July yet. Of course, who's going to believe this model? But still, if you had 1 degree anomalies that hung into July, we're talking almost another year of weak El Nino conditions into the fall of 2015 into the winter of 2016. This would be good, a multi-year event. And this is not abnormal when you have very weak El Ninos, or the Modoki flavor of El Nino, which is El Nino but not quite. That is, you get this sort of a long multi-year, just barely El Nino or just under the threshold. What that does is you get a multi-year momentum building up in the atmosphere from all the warm water, and then that's good. I mean, then the storm machine really gets cranked up. You get embedded periods of strong storms, and then it kind of slacks off, but you don't end up like where we've been for the past 3 years, where there's no energy in the atmosphere and just nothing can get going either in the summer or in the winter. So if one were to believe this sort of a scenario with this long-lasting warming going on, that'd be great news. And even if temperatures were only 0.6 or 0.7 degrees, that's perfectly fine too. A 1 degree multi-year El Nino, that's almost too much to ask for. So we suspect this is probably a bit bogus, but still, it adds credence to the thought that maybe a long-running event is in the works. So to wrap it up real quick, looks like the North Pacific is coming online. In the meantime, southern hemi swell is pushing towards California, hitting Hawaii. Nothing particularly impressive, but decent swell nonetheless. Swell also is going to be working its way from the north towards California and maybe a little bit towards Hawaii, with more on the models behind that. And then long term, certainly the El Nino forecast is looking favorable, maybe not strong, but maybe multi-year. That's what we want. And many thanks to our friends at Vunabaca.com. Check out their website, Vunabaca.com. Check out the building construction going on in Fiji at the new residential community there. And in the meantime, go get some waves, have some fun. We'll do this again next week. Same time, same channel. Thanks. Bye.